So that's where we embarked on looking at self-supervised learning. This is another paradigm that you recently come across in multiple contexts, and also you heard a lot about talks about ChatGPT and other aspects of it. How do self-supervised learning can help in learning from the data without much of label information which is out there. So this is something which we use very often in our work because of the kind of nature of the data sets that are available to us. And another aspects of it you can look at is something called foundation models, which is also becoming a reality in every areas of medical diagnosis. So what we can see here is this is one such foundation models that was built for histopathology using millions of histopathological data sets as well as associated clinical reports that can come with it. So having this, you can ask several such tasks, because this is something we talk about in the morning. Also we talked about generalized AI. So can a single model can do multiple tasks. So this model can do, say, 20 or 33 different tasks that we are discussing here. And you can also do something like image to text generation or text to image generation using such foundation models. So in that sense, you are seeing the world is moving fast in terms of adopting or coming up with these foundation models, and where are we in the space as far as our healthcare setting is concerned. So this is where our data set is going to play a big role, because this is one of the data sets which is unique to India, and it's one of the largest from India in the context of pathology. So using that, we are able to do several such work, but I'm not going into the detailed part of it. So one big thing that we are looking at is how to combine such approaches, right? So we saw different paradigms of machine learning. So here we are looking at self-supervision is one of the model framework where you don't need the label of the slide images, and you can think of foundation models which have seen n number of histopathological slides, and now it gains the information that comes from those slide information. And then how do you combine with the weakly supervised framework, which only slide level data that is available to you, the annotation data available to you, to do several such tasks. So that's a paradigm that we have adopted to build such models. And what you also see here is, in this context of the idea of how to do this modeling framework in the context of our data, we were also looking at what are the other things which we could do. So one such things I just skip few slides here, is to look at the idea of bridging this gap between histology and genomics, right? So this is one of the other aspects of it. So there are several applications which have been built based on these data sets. You can go and check on this page called ipd.iit.ac.in, which gives you information about what has been done with these data sets. The other area which we are focusing on is to bridge this gap between the multi-scale nature of the data, which comes from the tissue level to all the way to what is happening at the genomics, right? So this is a gap that we wanted to fill in terms of our understanding. So we have invested a lot of efforts into understanding the cancer genomics. Oncology is one of the area where we are excited about it. How do you analyze these kind of data sets and make some kind of interpretation that could be combined with histopathological data for any downstream tasks that we could look at? So that's one of the other areas that one can think about when we say AI in healthcare applications. And one application that I would like to talk about is something which possibly becomes useful, is to use, say, if I go to a clinic where I could get my DNA sequenced, and if I have the information of those, where are the changes that are happening in the DNA, can I get an information about any aspects that you're looking at? Say, for example, a cancer patient who's interested to understand how long they can survive, right? So they can use this information of the somatic mutation changes that could be extracted out of those genomics. Using that, we have built a pipeline which possibly looks into the several aspects of the different survival rates that patient could have, right? So therefore, this is one of the applications that comes from connecting the histology to the genomics. So having said that, I wanted to wind up saying that this area itself is exciting because of the real biology that we are looking at, right from the tissue to all the way to what is happening at the level of the genomics. So what we think as we move forward in the space is what we have been discussing so far, where we'll be integrating several data modalities. One such data modalities which we discussed is pathology. The other aspects is genomics. Now we are talking about integrating radiology and other clinical data, which could be used in the context of, used in the form of what is called generalized AI, where you can query them for various different tasks. So with this, what I wanted to convey is that we are not ready as far as we talk many things about technology in the space of AI in healthcare in India, because the data set that is available for building such tools or technology is still lying in the hospital, right? So how do we leverage that thing into the context of how technologies will work with them to bring a technology which is having a focus towards Indian context is where the challenge lies in. So this is where we believe that building such data sets are going to change the way how possibly the healthcare and the academia or the industry will work together. So thanks for this opportunity. Yeah.